You didn't take that.
Oh, yeah, they plug it in, thank you. Hey, you want to get your handouts later? All right. You ready? Bless you. Now, that's good, because we're doing virus. Anything else? I'm trying to give you some more entertainment as well as teaching, so. Look at this small one here. Make sure I'm not slowing down. Viruses. Now you're sitting in class, then this happens.
So let's say that this guy has flu, could be
Let's do
anything.
that one more time. Yeah, that is such a gorgeous picture of sneeze. And that's what it does. It spreads where? Everywhere. Okay, viruses can't hunt you down. They're not mobile. But they're like a bunch of particles that are going around in the wind, and they'll get you.
So let's say that this guy has the flu, could be any flu, and here's a droplet from his sneeze containing, if you move in and take a really close look, see each one of those little purple things is a virus. And there are a lot of viruses floating through the air, some of which go inevitably up this unfortunate man's nose. How did that guy feel when you ripped off half of his face?
It was interesting because we did it while he was sleeping.
Okay, I am talking with medical illustrator David Bolinsky, who designed this video for Xyrus and Research Company. So here comes the virus, and it's going to land on one of this guy's throat cells. So notice it's covered with little yellow knobby things. You call these keys.
Glycoproteins.
Is it a key? Is it a key? Is it a key? Okay, if the keys on this virus happen to fit the locks, which are those little purple stick-uppy things on the surface of the cell, if there is a match, the cell, watch this, welcomes the virus in. And what's this?
This is the welcoming committee. They all interlock with each other, and they pull this membrane down into the cell.
And down it goes deeper and deeper, and that welcoming structure disperses, and the virus capsule bursts, and out comes the secret recipe for how to make more viruses in those little needly things. So this unsuspecting cell has been tricked into guiding these virus recipes right into its own command center, the nucleus. So here we go.
And they are immediately recognized by this big pink molecule, which is a mini factory.
Yeah, what is it doing?
It threads the nuclear material, the instruction code of the virus, through one hole, and out another hole comes a brand new instruction set.
So it's a copying machine making copy after copy after copy of virus recipes, which then go out of the nucleus to little chefs, those blue peanut things. They cook up proteins that go back into the nucleus where they are reassembled into baby viruses, and then out they go. They get covered up and head to the surface where they get new keys, and then boom, here they come. This is an eruption of virus.
That's influenza. Influenza. And sneezes can travel a long way. Okay, let me get this clicking started and stop. Influenza is an animal virus, so it's a little bit different than what I'm going to start off with, which is these simpler ones, which are the bacteriophages. If I say bacteriophage, that means it only attacks bacteria. I'm going to go over a couple things. I'm going to flip to the focus notes. I'm going to come back to some more presentations with some visualizations. And I hope I have time for them. If not, I'll try to have time for them later. And the first thing we're going to work on, I'm going to pull the focus notes. I've got this machine overloaded. I've got some news on it right now. I'll talk about viruses. They are not considered alive. This is the focus notes. They're considered acellular. When you see the word A in front of something, like aseptate means no separation. Acellular means they're not considered to be true cells. They are not, there's no organelles, there's nothing. They can only replicate if they're inside what? A host cell. Inside a host cell. They take over, and these are the 5 stages, always in some form. Attachment. Remember they said that the glycoproteins and receptors on the host have to match. Have to match. The jigsaw pieces don't match, the virus just bounces off and goes away. Bounces off and goes away. Has to match, host to virus. Attachment, then entry in some form. They showed membrane fusion, which I'm going to get to with animal viruses, but what I'm going to talk to you about a little bit is direct entry in a minute. Direct entry means the outside of the virus, the capsid stays outside, and only nucleic acid goes in. So, attachment, entry. Then you can have replication. I don't use the word synthesis because that confuses people sometimes. Replication of viral parts. And then you have to put parts together. So, assembly, and then release. And then release. Release can be several ways too. This is so interesting. Viruses, common colds, there's more than one cause. Influenza killed more people than almost anything else in 1918, yes.
I'm just curious, did you say they're not live, but then they say that they give the live flu virus, like through the nasal?
That means they give the actual virus and not a piece of it.
Okay.
But that's in the gray zone. I've heard commentators in the evening news go, the virus E. coli, and it's like, no. Or the bacterial flu, and it's like, no. Okay, they mix them up. I had one person come back from somewhere, some clinic, and they were told they had a bacterial virus infection. Okay, it's a bacterium or it's a virus. It can't be both. Herpes can be those fever blisters or genital. SARS was severe acute respiratory syndrome, came out of China a couple of years ago. AIDS, you know that's HIV. There's many, many, many viruses. This is where I'm going to go first. There are 3 shapes. 3 shapes. This is the polyhedron shape. If you don't have this handout, let me know. Okay. 3 shapes. Okay, anybody else? These are ones we after that. Any more? Anybody else? Okay, so we're going to go over shape first. Anybody else? Viruses, all of them, have a center of some sort of nucleic acid. It can be RNA or it can be DNA. It's not both. It can be single-stranded RNA, double-stranded RNA, single-stranded DNA, double-stranded DNA, but not both, one or the other. This is flu. Flu happens to have RNA as its nucleic acid. Now, surrounding the nucleic acid, and yes, other viruses can have other parts, such as they can have some enzymes, and etc. There is a shell. There's a shell that holds that nucleic acid inside. The shell is called the capsid. The shell is called the capsid. The capsid is always made of protein. Made of protein. So the capsid is made of protein. Now each one of these triangular faces, this is like taking a soccer ball and flattening down the different faces. This is an icosahedron, icosahedron, because it has 20 faces. All the balls of all the different faces are called polyhedrons. That's just now. Each different one, 10 faces, 12 faces, 20 faces, has a special name. So 20 faces is the icosahedron. That's your influenza. Each one of these faces, it has teeny little balls of protein. So each little ball of protein is called a capsomere. Capsomere. So you might want to have 100 little balls in one triangle with the capsomeres being the little balls of protein. Put all together, you have the shell. The shell is the capsid. Capsid. that is as far as it goes for bacteriophages. A bacteriophage or phage has the nucleic acid interior and the protein capsid in, period. If you're moving to animal viruses or eukaryotic viruses, you can or may not have the next layer. Some animal viruses are called naked. That means they're just what we described. Nothing else. The naked was considered nothing else added. Others are called enveloped viruses. Enveloped viruses. They have their capsid buried inside, deep inside a ball of, guess what? Phospholipid membrane. But it's not a cell membrane. It's not a cytoplasmic membrane. It's just a phospholipid bilayer. It is inactive, cannot make ATP, cannot retransport. Either there and also sometimes on the capsid you will have glycoprotein spikes coming out. And they have protein receptors like jigsaw pieces on the end. Remember he said keys? If the glycoprotein matches what? The host cell, they lock, you just got attachment, then you're going to be infected. In fact, some of the medicines they're trying to research are trying to stop what? Stop that attachment. They can't attach, they can't infect. A couple of thousand things that are important immediately. One, do you know where flu got his envelope? Don't ever call it a cell membrane, it's an envelope. What is a phospholipid bilayer? He ripped it out of your cell when he came out. He ripped it out of your cell when he came out. Virus does what? Takes over the host. Forces the host on its cell membrane to, guess what? Make glycoprotein spikes for the virus. And the influenza capsid goes up to the surface and buds out and rips off a layer of the phospholipid membrane, its envelope. It made your cell make it what? Glycoproteins. That's what it did in that movie. And then if it bounces into something else, it's going to attach. Okay. I'm going to come back to this because I now want to draw a little bit about, I'm probably going to have to fight this thing to get it back on. I want to draw about cycles of viruses. How do viruses work? We have two major phases. The nice thing about this, you learned some of it when you learned transduction. Remember transduction? Carrying DNA from one point to the other with a virus. So you probably know a little bit of this already, which is good. Show up. I need 3 months. Innocent, harmless, bacterium going through the environment. I'm going to teach you about the lytic cycle for viruses and then the lysogenic cycle of replication for viruses. So this is how two loops for replication. You have your chromosomal DNA. In this case, it's called a T4 bacteriophage. If I say phage, you can only attack who? Bacteria. It also happens to be a DNA. This virus is always and only has a cycle, a lytic cycle. To lyse something or to be lytic means to do what to the cell? To break it open, crack it open, disintegrate. Well, you're going to have what? Attachment. Of course, you have to have receptors match. In this case, unlike the flu animal virus, the viral genome is injected into the host. So attachment, injection of viral nucleic acid, which is entry. What was the next thing? Replication. Well, of course, you're going to break down some of the host DNA, force the host to make viral pieces floating around. Replication. Then you're going to have assembly, force the host to put everything together for you, put the DNA back in. Once you have hundreds, and you've used up eating the host cell from the inside out, you're going to do what? crack it open, which is called lysis. Virus breaks out and is going to bump into the next healthy cells and spread, correct? You have fever boosters, that's probably what's happening. And if your fever booster is active, the little clear area is where the skin cells have been completely disintegrated. So what's been released? Viral particles. They're going to bump up into what? The next layer of cells. They're not infected, they're going to infect. Now that's the lytic phase. It's a little bit different for a lysogenic. Think of a lysogenic phase as being quietly inside the host with a subloop where it can go lytic. So lysogenic is a loop where it's quietly inside the host, and a subloop can go lytic. Let's start over. I haven't moved those two. Bacterium. The example for this, for bacteriophage, is always lambda. Lambda is still a DNA virus. Doesn't have the tail and the spikes, and is a little bit different. He, however, can become lysogenic. Lysogenic. What happens here is starts the same way. Attach, okay? And he actually has a little bit of enzyme lysosome, so he dissolves at that time again. Puts in what? His DNA. Capsid stays outside. With both of these, the capsid stays outside. Direct entry. Except to become lysogenic, I said quietly in the host chromosome, incorporates into the host chromosome. Now he can give the host a few extra traits, or he may be completely silent. If you're talking about a few extra traits, did I not ask you to know what some lysogenic phages were that affected certain organisms to make them pathogens? Cholera has a lysogenic virus in it. That's what enables it to make you sick. Okay? Also, diphtheria, lysogenic phage in there, makes the organism a pathogen. Now, he's quiet. There are no virus particles breaking out of this, but he can still expand the population of virally infected cells. How does he do that? Through the offspring. Every cell that comes from the infected mother cell, and every cell from that line on, is what? Infected. Every cell is infected. Now, there can be, and these will continue, let's say a trigger hits one of these cells. Trigger is not the correct word. Scientific word is to induce or induction. Induction or to induce. This can be done all sorts of ways. Radiation, UV light, X-rays, chemicals, food you eat, things that are in your food, or your blood chemistry changes. Some sort of induction. Induction means that little bit of the virus is going to now become active, as in lytic active. So it's going to become active. This virus is going to go over to lytic cycle, which is what I just showed. We're going to make what? More viral parts. Then you're going to do what? Assemble them, and they're going to do what? Lyse the cell and break out. Because it's now actively full replication. Now these viruses can go either way. Some can go back and be lysogenic and become quiet again. Maybe this one's lysogenic, that one's lysogenic, this one's lysogenic. Some may continue to be lytic. And lysogenic, they're what? They're quietly within the host chromosome. If they're lytic, they're doing what to the host cell? Breaking it up. Fever blisters. You have a bad test coming up. Microbiology just really bothers you. Your blood chemistry goes from calm, because you have a nice meal, you're having fun with your family, to stressed. Stress is different chemicals in your body, okay? Production through chemicals. You have it's not called lysogenic in animal cells, it's called latent in animal cells. Latent virus in your skin cells, it's been triggered, not all of them, some of them stay quiet. Those triggered ones do what to your skin cells? Lyse. And you get the fever blisters. Then, of course, you go back to lysogenic is only for bacteria. A similar state for animal cells are eukaryotes. You don't say lysogenic, but it's the same thing. You call it latent or latency. Latent or latency. Bless you. Same thing from chickenpox. Chickenpox starts off with the little pox marks, or now they show vaccination. What can happen when you're older and your immune system's a little bit more impaired? You can get what? Shingles. The virus, in this case, is an animal cell, latent in your cells. You're okay if your immune system's up and running right, or if there's no trigger induction. If it happens, it's now in your nerve cells. Triggered means it becomes, at least some of them become lytic. And then you get what? Shingles. Now, not all of them, because you can always get shingles again from others that are held back.
If they've had the chickenpox shot,
They can get shingles.
because they still get shingles.
Yes, I asked that. It's a great question. I'm so excited you asked that. Because I asked a doctor that precise question. I said, you're giving all these kids, as a pediatrician, shots for chickenpox. I said, can they get shingles from this vaccination later? He said, yes. Okay, yes. Oh, you need to get the shot. So you need to get the shot. Yeah.
Why do you need to get the shot if you can still
It's a shingle vaccine now, so you got a second layer. But you need to protect yourself from chickenpox first. Y'all heard about the person with the popsicles on chickenpox popsicles? Okay. You still want to protect people because chickenpox can be very serious for adults, so it's not as serious for children. And shingles, there's a vaccine, another one, for the second layer. Okay? Remember, it's always catch up with microbiology. Catch up with it, catch up with it, catch up with it. A lady got in trouble on the internet. Well, let's go back a little bit. Are any of y'all as old as me that remember people used to have chickenpox parties? Yes. One kid gets sick, you invite all the kids in the neighborhood, get together, get them all through it at one time. Okay? Well, yeah, vaccines now. Well, she took it a step beyond that. She collected the pox and made it into little frozen things and was selling it over the internet to people who wanted to buy it anywhere in the country. First off, I wouldn't buy that, okay? You never really, there's no quality control, there's no lab, there's no nothing. It's just scrapings off of different children with chickenpox. And she was making money, but you can't do that on the internet, so they shut her down. Hopefully she's not back under the radar. Okay. So, lysogenic and lytic. Well, there's still people that take word makes on the internet, so that's not just where you live. Okay, now, this is again the polyhedron shape. Polyhedron shape. Well, no, I'm sorry, that's not polyhedron. Polyhedron is your blue. It has a polyhedron right here, but because you have this extra part, do you remember me telling you that science always has a group name for where nothing else fits and they throw it into there? So complex. This is a complex virus, the T4 and the lambda, with its polyhedron and cosahedron. Yes, it does have a polyhedron head, but it also has extra pieces. There's one more shape for viruses. It's called helical. Helical.
Is that the same for the upside down line?
Lambda. There.
Upside down line?
Huh?
It's an upside down line?
Yes. That's the cycle. Lambda. And even the helical is still, it's like taken a straw that's hollow, and the outside of the straw are all the capsomeres, and it's the capsid, and in the center and the hollow part going around is the RNA or DNA. So you still have the core structure. For complex, that's rings. People say it looks like a bullet. Always looks like a bullet. If you ever see some sort of virus of some type, and inside, I can't find hourglass. Bad hourglass, and there's an hourglass. You should never see this. That's smallpox. You should never see that. It's supposed to be wiped out. Okay? Does that make sense? So a little bit on the shape. I'm going to go a little bit now. I'll pick some representative samples right here. Who it has families and just list them out. Right, 1, 2, 3. And go back to the footsteps in a minute and have some more movies for you. Anybody else? Everybody else okay? Oh, no? Okay. If it doesn't make it back to you, let me know, and I'll pass it on. Believe it or not, just like the eukaryotic prokaryotic chapter, I didn't have to learn everything, but it probably seems like it. These are representative samples, and yes, I'm going to add Ebola to that. Okay? And they're broken down into RNA viruses or DNA viruses. RNA viruses or DNA viruses. I'm going to start with the RNA first, a point of information. How you classify viruses. Well, are they RNA or DNA? Right there. There's one. RNA or DNA, single-stranded or double-stranded. Other one is by the, guess what? The shape. Polyhedron, icosahedron. Another one I'm going to show you right here at the top of the first one under family that says Picoviridae. What does pico mean? Very small. So sometimes the size. Pico means these are very, very small. So far, RNA, DNA, nucleic acid, bless you, shape, size, sometimes according to what disease they cause, and the way I don't like, which is named after the researcher. I don't even tell you anything about the virus. In other words, how do you name them? Many different ways. Many different ways. And you just sort of have to learn the name that matches the virus. As soon as you see the term viridae, viridae is an organized point. It means virus family. Viridae always means family when it comes to the virus. So Picoviridae means very small viruses. You know they're all RNAs. We have enterovirus, polio. I say E-N-T-E-R-O. Many times in microbiology I want you to think intestine. The enterics, the enterobacteriaceae, the enteritis. What is it all? Intestine. Polio goes to your intestine first, and then of course causes later paralysis of your muscles. If I can get time, we have a movie for that one. Hepatitis A, you know the different hepatitises. Heading 4. Liver. The liver is very important. It cleans up your blood. It cleans up everything. Liver is very important. Rhino is one of many. There's more than one cause for the common cold. But rhinovirus means good. Okay, so that's sort of there. All right, moving down to Tocoviridae. Rubella is the type of measles. As soon as that pediatrician hears the child's coming in with spots or rash, what do they usually do? Put them in a room off by themselves so they can see them. Because highly contagious. Highly contagious. Coronaviridae is named corona because when I get a chance to show you these, and I'm going to show you some pictures in a chance, it looks like a crown. It's a circular, of course it looks circular, but it's got all, you know, this crown has all those spikes at the top going around, has all those at the top. This one, coronavirus, SARS, was the one that came out several years ago from China. Severe acute respiratory syndrome. Can also cause common cold, just like the rhinovirus. The SARS, they did an epidemiology study. What does epidemiology mean? study of where they come from, how to transmit, how to stop them, character, etc. Started in China, and then there was an international medical convention, and everybody, all the doctors from all over the world, including ones from China, went to the medical convention. Some of the doctors didn't know it, but they had SARS. Everybody hopped on a what and went home? Airplane. So it went through the whole world. Well, airplane, yes, and through the whole world. Okay, coronavirus, you need to add one to that. Add underneath SARS, this one's not talked about right now because everybody's talking about Ebola. MERS, M-E-R-S. M-E-R-S. People have completely stopped talking about it because they were worried about it about a year ago. Middle Eastern respiratory, okay? So it's coming out of the Middle East. They're worried about it being like SARS, which means a severe respiratory problem. And they had the first documented jump. It comes from an animal in the Middle East and jumps from the animal to people. Zoonosis. Camels. They have a documented case of a camel owner herder who literally was treating the nose of his camel, which was running because it had fingers. Okay? Sneeze in his face. Camels also spit very well. Okay. And he got MERS. I mean, you can't ask for a more clear-cut case than that. Coming down to retroviride, okay? Of course, leukemia virus, I'm going to say AIDS, which is a lentivirus, but I'm going to say HIV for that one also. Let me give you some background. Also, let me slow down so people are writing real fast. So,
What does the S mean for Mars and
severe acute respiratory syndrome. Okay. Okay. Coming back to retroviride. Remember genetics. Transcription means what to what? DNA to RNA. If you reverse that, RNA to DNA, that's called a reverse transcriptase enzyme. In this case, it's reverse. Retroviride means they have reverse transcription enzymes. Whether RNA viruses, what's the first thing they're going to make from that? Because they have those special enzymes. They make DNA. So HIV is that type. That type. Next one, I'm just going to ask you about influenza virus, which I'll tell you something about that one briefly. I got to be sure I cover this. Ebola, nothing compared to the swine flu or Spanish flu of 1918. It killed more people than World War I. The life expectancy of the United States dropped by something like 14 years. It didn't wipe out the old, it didn't wipe out the young, it wiped out the us and the middle-aged. Well, two waves occurred, and one thing that's going on upon time period was World War I. Take all of our troops, put them on troop ships, stick them on the ocean, confine them in close quarters for months at a time, send them across, expose them to the wave in Europe, or maybe also have some here, put them back on the ship, close quarters for several months, bring them back home to our ports, let them all go home. What happened? It was a pandemic. You know what pandemic means? The whole world. It killed and killed, and it killed healthy, middle-aged people. Used to, in the military, you didn't want to get a Western telegram because it's always something like, I am begged to report or sorry to report the death of. Never wanted them. There were more sent out for influenza in 1918 than were sent out for anybody being killed in the war. Now, flu. Flu virus is unique. It has something called antigenic drift. Remember we said the pattern of the virus has to match the pattern of the host for them to attach. Well, flu starts in China. There's different theories, but the bottom line is we don't really know why. Okay? It starts in China. Some people say it's because of the rotation of the earth. Some people say it's because of the climate. We don't know. And I'm not going to ever claim to know something I don't. Flu goes into the birds, the ducks, the geese, and the pigs. What does it do inside those cells? Replicates. When it comes out, it has, during the replication, and also as it's floating out, it changes its patterns just a little bit. They're called antigen. Antigen is any pattern that causes your immune system to respond. Antigen is any pattern that causes your immune cells to respond and protect you. Especially changes those glycoprotein spikes. You ever hear one of what? Two names of the glycoprotein spikes, since it's spelled in your focus notes and in your textbook: hemagglutination and neuraminidase. Hemagglutinin and neuraminidase. H and N. What do you call your flu virus spike? H and N. What's changing? Amongst other things, the patterns on the glycoprotein H and N attachment spikes. So when the flu virus comes out and comes from China and away the next year, our immune system's ready for last year, but what's coming this year? Something completely new. Neuraminidase. N-E-U-R-A, and it goes up. I can look it up. M-I-D-A-S-E. Okay? Now, here's the catch. We send teams over with the CDC, and they try to check the ducks and the chickens. They don't actually have pictures of them just killing all the chickens in the whole market because it has a virus they're afraid of. They'll take them, kill them all, and incinerate to keep a wave that they're worried about from coming. Okay, pigs, geese, whatever. They pick 3, 5, whatever strains they think could be forming, put them into a cocktail, stick them all into chicken eggs, and they make our what? Vaccine. Okay, vaccine. And you know how birds can be in danger. Birds migrate, right? And people are in close association with birds, you can get it from a bird. Birds also do what as they're flying? They'll poop right in the air. Didn't know if you wash your car, find that out. Pigs are worse. What is the animal they are used to use if they want to do transplants to people? Pigs. Do you know why? Because the patterns, protein, antigenic patterns on the surface of pig cells are very close to humans. So if the viruses go into the pigs, adapt to the pigs' patterns, they're getting closer to humans. In 1918, before the pandemic, the pigs died. Lots of pigs died. And then they came out. That's one reason it's called the swine flu. The other reason is Spanish flu, because it was also in Spain. A year and a half ago, our pig population started dying, and they all had a lot of influenza viruses. People were afraid, but nothing happened. It wasn't swine flu, it wasn't 1918 flu. Price of bacon went up, but they didn't jump to us that time. Doesn't mean it can't in the future. Does that all make sense? Okay. All right, influenza. Lassa virus, which is a rhabdoviridae. Rhabdo is the name I know it more by. Rabies climbs the myelin sheath around your nerve endings. What does that mean? It's that sheath that controls the what? The electrical potential, the firing. If you're bitten in the calf of your leg, you're safer because there are fewer what? Nerve endings. And it's going to one place. It's heading for it's using it for a highway system to the brain. Nobody has survived rabies when it hits the brain. There are some rumors, but there's not a documented case of anybody living once rabies hits the brain. You are dead. Okay? What about your hands? How many nerve endings? A lot. A lot. It's more dangerous if you're bitten on your hands. Certainly if you're bitten on your face, because that's right there. Well, they give you the 21 shots to the stomach, and what they're really trying to do is give you some protection and also give you a vaccination, because it does climb somewhat slowly. Get your immune system what? Up, ready, and get you protected before it hits your brain, and you're okay. Won't help you once it's there. Okay? And what you know what they do when they say, I'm just going to check the dog, we're going to hold it in quarantine, we'll see if it's rabid, and we'll tell you about the child bitten later. In most cases, they're not holding that dog. They take it, they get a slice of its brain tissue, and they check for little black spots in it that are clumps of the what virus? The rabies. And if they see that, and sometimes they treat the child anyway, but you can't take a chance.
If you can't find the dog, we should money, and my son got the dog.
You've got to.
Face.
And got in the
He
face.
had 21 shots, and he had a face shot.
It's not 21, what is it
No,
now?
I think they do 6 different doses.
6 different doses?
Yeah.
Okay, where do they shoot them? In the arm now?
In the arm.
Okay, that's better.
He said it's like probably his past time.
I never had a shot in her face around by
You got shots in the face?
my daughter. She was only
Well, see, it depends on the case, so not in the face, right?
No, he got.
But in
the
the arm, okay.
Yeah, but it's 6 doses, and they reported to the health department.
Oh, yes.
Like,
It's
immediately, and
notifiable.
They went looking for the dog, they couldn't find the dog, and the dog had a collar, they treated him anyway.
Oh, yes.
Because they didn't know if the dog was.
Rabid.
Rabid, or if he just lost the days, or, you know what I mean, but he did have a collar, it was somebody's dog.
Yeah, but you don't know if they
couldn't
vaccinated
take
their
the
dog.
chance, right, of it having had rabies, because it chased him.
It chased him.
It chased him.
That's a crazy dog.
Yeah, and that's why I was like, no, you're going on.
Oh, I would too. And in the face, I gave shots around the face?
got it right here. They gave her shots around it. I don't know.
Around the bite?
Yeah.
Okay. That's what they're trying to do.
Yeah, that's what it is. And they didn't even want to pull it up because they said dog bites were so,
Nasty.
yeah, they have so many germs.
Organisms.
that-
This bit about dogs have cleaner mouths than humans. I mean,
It's not true. They said their mouths are the filthiest.
what do they put in their mouth?
They needed
Everything.
stitches, but they couldn't do the stitches because they needed it to take
To
over.
stay open to us.
It was nasty. It was a nasty bite for a pit bull.
Y'all seen what dogs lick? Oh, pit bull. Yeah, I like, oh, God. I know what they do this, they do.
No, we have a pit bull.
No, I'm not saying, I'm not knocking pit bulls, we're not attacking pit bulls, okay? I'm just saying the bite would be bigger than if a little chihuahua
Right,
bit.
it was
So
a
it's
big
like,
bite.
a what? Will lock. Do you know what people used to do in the country with dogs? When people want to get rid of their dogs, they used to go out to remote places in the country and they abandon their dogs. They can live in the forest. Do you know what dogs do? They band together in packs, and if your dog gets in a pack, it will attack you too. This is a problem out in the country, and also for other minor parts. Raccoons are one of the worst sources for rabies right now. Because the dogs are vaccinated. Like poor old Cujo. Those poor people in that car couldn't get out. Okay? Raccoons are a major source of, and they've got needle teeth. And if you ever grab a raccoon by the back of the neck, what does it do? It curls. It has very loose skin. It'll get you. Squirrels can't. Squirrels can't. So I got a brilliant son who went out when he was a little kid, decided to hand 3 squirrels in his heart. Squirrel attacked him, bit him. Okay, I'm thinking rabies. So microbiologist mom learned something here, and I'm always like to learn. Took him to a pediatrician. My son just got bitten. This is the medical doctor. Okay, squirrels cannot carry rabies.
Really?
Squirrels cannot carry rabies. Okay.
Or do they carry it?
Something else. Well, if you eat squirrel brains, they carry a certain type of, I think it's a virus, I can't be sure of that if you eat it, it will get into you and will break your brain down. Okay? So don't eat squirrel
Can't
brains.
get it, because by the time, well, not so much that they can't get it, but that by the time it actually travels through the squirrel's body, it would die before it even got to you. Like,
I just know he said they can't carry it. We got some stupid squirrels in our neighborhood. You ever heard of the, I gotta get over, I'm gonna say one more thing. You ever heard of the sacrificial squirrel shuffle? You're driving down the road, maybe 5 miles an hour. Yes! And the squirrel runs and darts back underneath your tire. There's no way to miss that thing, because he's trying to get underneath your tire. My kids told me I killed Squeaky and I didn't mean to. Okay? Squeaky didn't die. He moved to another neighborhood. Rhabdoviridae. Rabies. Okay, rotavirus, severe diarrhea. That's another, well, it's a Rioviridae. Severe diarrhea, that's more dangerous for children. Definitely for children. Replace the fluids in their electrolytes. And we're going to switch to the DNA side. See, we're awake. This is how you learn. You learn because you talk to each other and you do it as best you can. Now, DNA viruses on the back. Fever blisters we talked about. Another type of herpes genital. I mentioned varicella, but know that varicella is what? Chickenpox. Epstein-Barr is a bit, we could have some more information on this one day. Epstein-Barr in the United States is self-limiting mononucleosis. Mono. It's right here. Right here. This misnamed. People say it's a kissing disease. No, it's very contagious. Well, not very, but it can be contagious. You pick up a glass that they drank out of and you take it somewhere to go clean it, you can catch it. You clean a bathroom, you can catch it. You don't have to kiss them, okay? Toothpaste, yeah, that's a good one. Water fountains, yes, if somebody, oh, don't share drinks, please, okay?
Share makeup with someone, can't you get it there?
You can get a whole bunch of things.
Yeah, don't wash your makeup, don't do that either.
Yeah, even that.
Y'all are nurses, you know not to do these things, okay, right? Okay. But, Burkitt's lymphoma in Africa. What does lymphoma mean? Cancer. So that's a little bit more work to do there. Cytomegalovirus birth defects. Coming down to papillomaviridae in the center. Papillomaviridae. Well, cervical and penile cancer is not anymore because we don't give the what. Well, I mean, you can still get it, but for the newer generations, you have the what? Gardasil, the vaccine, for ladies and for young men. And on the other side, benign warts. Warts can be very, very contagious. I know of a dermatologist case where a young man came in, his whole back was warts, and the shoulders all the way down. They did chemical burn and some liquid nitrogen to get them all. And what she told me was she would not allow them to share the bar soap, share the towels. Everything in the bathroom had to be separate. They had to move to the squirt soap only, and one for each child. Because it could jump. Get your own bathroom. None of us, I don't think any of us are that rich. Okay. Hepataviridae, of course, is another type of hepatitis. And we end up at the top with smallpox, poxviridae. Smallpox is technically non-existent. The case for this, yes.
Go ahead. I have a question. On the RNA side, it says all are single-stranded except one. Did you say this one was double-stranded? And I missed it?
It's the one at the bottom, there's double-stranded right there.
Oh, okay, I'm sorry.
I'm probably not going to go that fine on you, but I do want to know if it's RNA or DNA.
Okay.
That's good. Always ask. You're right to ask. Okay? Smallpox supposedly had as a host only human beings and nobody else. Okay. Last case was cleaned up, cleared out. It's been a long time. Yes, they did have a brief military type of vaccination when they were vaccinating people to protect certain military medical personnel. Yes, they did tell them after they had the scab to take it and put it into a Ziploc and put it away. No, the following rumor is not true. They're not vaccinating people with smallpox. What did Jenner use? Cowpox. They were using cowpox. Still using it for the same thing. And the only thing they wanted was just to keep it from being, keep it neat, keep it clean. So, most of us are not protected. Let's give you some history. When the Europeans came over to the New World, amongst other things going on, smallpox was endemic in Europe. In fact, women in that day, Joey heard, would have pox marks and you'd use the wax type of makeup to try to fill in the pox. American Indians, natives, had never encountered smallpox. Entire villages became ghost towns. Nobody left. Wiped out because of smallpox, because nobody was immune. Okay? The same thing could happen to us. It can flip. If some sort of virus comes that our whole population is not exposed to, what happens to us? Same thing. Yes, they still have vaccinations and they have stock, so if it ever does happen to show up, they would have massive vaccination schedules real fast. If you're really old, if you ignored the recent little military blip, you will have a small circle right here. That was a smallpox vaccination from a long time ago.
My sister had that, it was really
I don't
a lot of immigrants, a long time.
Yeah, I've got that. It's a little pink circle right there, but the protection's gone for 5 years. Oh, you get a spot. Okay. Two places still have smallpox in the world for sure. Not meaning an infecting agent out in the world. In laboratories. What two places? The CDC in Atlanta for study purposes and maybe vaccinations. Who will be the flip side? Russia. Russia has it. Russia would have the other ones. That when the Soviet Union was falling apart, one of their fears were bioterrorists getting in and getting some of their strains. Ebola, you can add to this. Ebola is a bleed-out disease, causes massive bleeding, of course, attacks. It is only contagious by body fluids. It is not airborne. If it was airborne, we wouldn't be here. Yes. Just add it randomly. Add off. Yeah, just put it to a side by itself, because I have to actually find a family name for it. A sneeze? Sneezes don't usually count because there's not quite enough.
DNA?
But it is a DNA.
But I have to look that up.
Oh.
So just put Ebola right down the circle and put body fluids
Ebola's
on
been
it.
around for like a long time.
Yes. In fact, it's been in Africa for a very long time. They've had outbreaks every year for a very long time. First they thought it was coming from the monkeys, and then they changed to think it's coming from the bats. But now it's coming from the bats. Okay? And there's also Marburg over there, which you have to put down, which is another one, but it's sporadic appears. What's sporadic mean? From that. Most thing I'm trying to tell you about Ebola is not telling so much about families that are up. They're not going to be wiped out today. Right? It's not going to wipe out the United States. It's not going to create the zombie apocalypse. Everybody's going to create the zombie. All right? Don't do that. And a lot of people are going to tell you we are didn't. We're not doing it. Is it nasty? Yes. It's nasty. 1918 makes it look like a mouse. Okay. All right. I'm going to go back to the focus notes. And maybe I have time to show you some of these movies. No, I'm not. I want to do one more thing. We're going to do animal viruses real quick. Then I'm going to animal viruses. How many times have people told us the world is coming to an end?
Almost every year.
Wasn't there an asteroid that was going close by in the last year or so? Was supposed to get wiped out? Are we still here? Okay, animal viruses, we'll do that and then go to focus next. Now, if I say the virus cannot have an envelope inactive phospholipid membrane, it has to be bacterial phage or phage. Animal viruses can be naked, which means it's just what I talked about. You have the nucleic acid with a protein the nucleic acid with a protein capsid, or they can be enveloped. Guess what? It's another way you can tell if a virus is enveloped or not. Enveloped viruses are easier to kill than naked viruses. You can mess up those protein receptors easier. Okay, a little tweak about the flu. It doesn't like humidity as much as it likes dry. There's some of the tweak. So it tends to break out in the winter time periods where things are a little bit less humid. Tend to get colds, not always, this isn't written in stone. Tend to get colds in the summer, but not usually flu because the humidity is higher. Not written in stone. Now, animal viruses can enter in 3 ways. Enter in 3 ways. One is just what we talked about, direct entry. Capsid stays outside, nucleic acid is injected. Other one is called membrane fusion. about it. In this case, it's an enveloped virus from membrane fusion. The virus has a phospholipid bilayer floating around in space, right? Your cell membrane is a phospholipid bilayer. When the two come together, what's going to happen? The bilayers are going to fuse. What just happened? The virus just got sent into the cell. Into the cell. Other one is taking advantage of your, you can call this phagocytosis or endocytosis. Either one's okay for me. The virus is depending on your phagocytic cell to eat him. What does the phagocytic cell do? Goes up, surrounds the target, brings it in a vacuole. Of course, the vacuole has a phospholipid membrane. And then you just did the virus a favor. You just brought him in, which is what he wants. With these two, there's a little bit of a catch, because they still have to deal with their capsid, don't they? Because it wasn't left outside. So if you have a host cell, let's say your virus gets in, and now it's in here, the flu virus, it left its envelope back with the cell membrane in most cases. You have to get rid of what? The capsid. In most cases, if that capsid is not removed, the virus cannot infect you. It will, of course, code for different enzymes from your cell, or it will have enzymes to do what? Break down the capsid. Breaking down that capsid has a real hard name. It's called uncoating, like taking off a coat. If you have an animal virus, membrane fusion phagocytosis, capsid is still there, goes inside. It cannot affect you until it is uncoated. Defined as the capsid being what? Broken down. Some medicines rely on that and stop the uncoating of the virus. Once it's uncoated, it's going to do what? Take over. Replication, unless it goes latent. Latent means hiding in your cell. Then assembly, then release. Now, release, we're talking about release, can still be what we talked about. These are still animal viruses. It can be lytic, which can happen, or a host cell can be released through a system called bless you. Virus taken over, uncoated, it's finished taking over your cell. It's forced your cell to make more icosahedrons, that's a terrible icosahedron. It forced your cell to make H and N spikes on the cell surface. Virus is going to head for the surface. What I say it's going to do? It's going to rip off part of the cell membrane, but it made your cell make what for it? The glycoproteins H and N. By the time that virus buds through, you have again an envelope with your spikes, and he's heading off to get somebody else sick. Budding. Host cell is still alive. Viruses are coming out to the environment, coming out to the environment, coming out to the environment. That's what? A chronic or persistent infection. What needs to happen to that host cell needs to be killed. It needs to be destroyed. Definitely needs to be destroyed. Because it's a source of what? Infection. And as I said, forces your cell to make everything it needs. Does that make sense? Okay.
The H and N, are they glycoproteins?
Yes, they're glycoproteins. They just give them special names. Glycoproteins with special names like, I don't know, curly-mollary. Okay? Give them special names.
And the one you did, that's budding, right?
That's budding. Budding is when the parents, well, the host cell stays alive. Virus comes up, rips off part of the cell membrane, becomes this envelope, goes off into its environment, which is usually our body. Then slowly, it just keeps happening, but the host cell is still alive. The host cell is still alive. Still producing. That makes sense.
So only in Lytic does the
And
cell
lytic, that
die
would be what we showed together, it would crack open the cell and it would leave.
and kills the cell.
Yes.
And then budding, the
The
cell is
cell
still
stays
alive.
alive. Which one do you think's worse? Budding.
Budding.
Budding's not good for us. Is that coming on this time? Guess I start indicating that. Oh, man, it's working. Okay, so glycoproteins. We talked about enveloped and non-enveloped. Easier to kill envelope virus because you can mess up the what? The receptors that would cause attachment better. Shapes, polyhedron complex, the bacteriophages, T4 and lambda complex. Classification we talked about, okay? RNA, DNA, envelope, shape, or size. We talked about some of this, and we just more terms, you know, phage simply attacks bacteria. Lysozyme is an enzyme viruses can have, which is also in our tears and our saliva. It breaks down peptidoglycan, which means what's the target? Only breaks down peptidoglycan. What's the other thing that has peptidoglycan?
Bacteria.
Bacteria. Well, that's your thing. Plaque, I'm going to show you a little bit later. You know how you have colonies that you grow up, they're bacterial colonies? It's for to find viruses on a plate. The viruses are lytic. Wherever they go into the bacterial cells, they kill them so it clears that area, like beta hemolysis. Clears everything off, right? So if there's a little clear circle, that means all the cells had to be broken and die, and they count that as one viral particle. That's called a plaque. They don't call them colonies, they call them plaques, and it's based on them killing off the host in that area. I'll show you some pictures of like that. Burst time and burst size. This is real hard. Burst time, the time from when it goes in till it comes out, being lytic. If it takes 20 minutes to do the cycle, that's your burst time. If it takes an hour, that's your burst time. Burst size is the number of viruses that come out. If 100 come out, what's your burst size? 100. 100. Lysogenic we went over. Prophage simply means it's hidden in the DNA. Provirus is hidden in the DNA. There's your term lambda. There's your replication steps. I changed synthesis to replication because some people were associating assembly with synthesis, so I just put replication in there to try to get some confusion out. Talk about lytic and lysogenic. Don't worry, I'm going to get you one more movie. I said some of your lysogenics, diphtheria, cholera, and some E. coli. What does that mean? The viral genome is silently inside the bacteria. So with animal viruses, we talk about direct penetration, endocytosis, and membrane fusion. We talk about budding, and we talk about naked animal viruses. Latency is the same thing as lysogeny, except latent means animal, lysogenic means bacterial. For latent, for animal viruses, it doesn't have to incorporate into the DNA. It can stay free, or it may incorporate depending on certain situations. Briefly coming to here, cancer. Okay? If you are going to have a tumor, you want benign or malignant? Benign, because it means it's not going to spread. Metastasis is the fancy word for spread. Some people say that the oncogenes or proto-oncogenes were viruses that got into our DNA a very long time ago. Generations and generations and generations ago. They can stay quiet until they are what? Triggered, induced. Something you eat, chemistry, could do anything. We don't know what all the triggers are, right? Now, you can have, some oncogenes are constantly turned off because there are oncogene repressor proteins that keep them turned off, 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 off. If a virus gets into your DNA and destroys the section of your DNA that makes the repressor proteins, what happens to the oncogene? It turns off, and you get cancer. Cancer. Other ones say that the viruses coming in can themselves directly turn the oncogenes on. in other cases. Is this truly known? These are theories. Does that mean, you know what that means? It means they're still trying to work out this system. And Carrie and Jennings calls it interfere with repression or turn it on. You know viruses have to be grown in living cells. Chicken eggs, tissue culture, even in animals. You can't grow them without a living host. Okay, viroids simply are plants, and yes, fungi can get it too. Prions. Come back to prions. I think I'll show you a movie, because I'm determined to show you at least a movie. Do y'all like hamburger? Do you like your meat? Well, it doesn't really matter how you like your meat. That's going to get you away. Right? Yeah.
So well done, doesn't make a difference.
Not in this one. Where if you ash it, it protects you. Absolute ashes. Okay? You remember Great Britain? They had, this is what happened. And it's, yeah, that's right. And they're telling stories. You're very not to do that. Sheep got sick. The sheep got sick. The sheep would go up to a fence and they would scrape the sides until they bled. So they called the illness scrapie. And does that make sense? Scrape sheep. Well, people wanted to save money, but they didn't know they were doing anything, so we're not going to blame anybody. I never believe in condemning anybody. They ground the sheep up and they made them into little pellets. Have you ever seen secondhand lions? They went and got the lion chow, like Purina lion chow. They ground the sheep up and they fed them to the cows. Cows started staggering around and dying. They got mad cow disease. They then took the cows, ground them up, and they fed them to people. People came down with Creutzfeldt-Jacobs, which is the human mad cow disease. Spondyloencephaly, encephaly means head, sponge means exactly what it says, puts blood in your brain. Holes, and you die horrible. What is the common denominator? Ingestion. It's always ingestion. Prions surprise everybody. They're not viruses, they're not protozoans, they're not bacteria, they're little teeny proteins. They're just proteins. Yes?
Did you ever hear about the story today? In some country.
And Papa Nikki, I gotta tell that, that's a good one. This, okay, I'll come back to this minute. Okay. There was a cultural tradition that, as an honor to the people that were captured from the best warriors from the other tribe, they would fix the people up and eat them. It was also an honor to honor your ancestors or your grandparents to keep them. And what happened then was the illness, which is natural disease, was called Kuru, K-U-R-U. And it happened more to the women because the women were doing all the work and the cutting and everything else. Same thing. It would eat the brains away. What the prion's doing, remember way back when I said the foldings have to be right in the proteins to have right function, but also in structure. So you have beta-fluted sheets, you have alpha helices. Prions come in and change all the foldings to the incorrect percentages, and they'll kill you. You cannot destroy prions with glycol, you cannot destroy it with an autoclave, you cannot destroy it in an oven, you cannot well cook your food, you cannot sit it in bleach for 4 years, it will still laugh at you. There is only one way to destroy a prion. Ash it. That's the only thing you can do. So, your hamburger well done doesn't matter at all. At all. Yes?
Can you get mad cow disease from dairy products like milk and ice cream?
Not from dairy products, but you can get it if you're a game hunter. There's also elk wasting disease and wasting disease for some deer. Very similar to venison, and if it's in there, they're not from the milk. They're not from the milk. So that's a whole different system. Yes. So some hunters have gotten it from making sausage from the elk and eat stuff like that. They are working on an enzyme, protease, to break down a protein. Do they have it yet? They don't have it yet. So prions are complete story into themselves. I want to see, I don't have to split you one movie. I really want to split you a movie. This one. That one. How many minutes? 3 minutes. Nope, I don't have time. I have to get to you next time. Okay.